We will discuss chemical kinetics in this video. Chemical kinetics tells us how quickly the reaction occurs or what is the speed of the reaction, or in other words, it is the study of reaction rate. Reaction rate is nothing but it is the change in concentration of a reactant or product per unit time. So how can we represent the concentration of a reactant? Say for example, a reaction A gives B. We can write the concentration of A by putting in bracket, and change can be represented by putting a delta sign in front of it. And the normal unit for the concentration is molarity, which is also can be written as m or moles per liter or mole liter inverse. All are same. And how can we write the rate is, spell the word rate. Rate equal change in concentration of reactant divided by change in time. To explain the change in concentration of a reactant product, let us see the graph here, and the equation 2NO2 gives 2NO plus O2. The reactant NO2 is decreasing in concentration when the reaction proceeds, and the concentration of the product increases as the reaction proceeds. So these two lines represent in different concentration because the ratio, the stoichiometric ratio between NO and O2 is 2 to 1. So if the rate expression involves a reactant, how can we write that one? By considering the change in concentration, that is decrease in concentration of reactant, is by putting a negative in front of the change in concentration of A. But if it is in terms of product, we will not write negative. We will just write change in concentration B divided by change in time. That equals. Let us see some examples. In this generic equation, A gives B, we have the stoichiometric relation 1 to 1. So it is simple to write, just like we were writing in the previous case. We can just write rate equal change in concentration with the negative sign for the reactant, and that equal change in concentration of the product B divided by change in time. But what if we have a different coefficient? Say for example, 2A gives B. The 2A, that means A disappears at twice the rate that B appears. So how can we write that one? How are we going to show in the rate expression is, we will put the coefficient as in the denominator, and we will show negative to show that A is decreasing. The reactant concentration decreases. So negative 1 over 2 change in concentration of A divided by change in time. That equal change in concentration of product B divided by change in time. So this is the point we have to remember. So the coefficient will go in the denominator. So here again a generic equation, AA gives BB, where A and B are the coefficients. So what we will do is rate equal negative 1 over A, because that's the coefficient, negative because that's the reactant. So 1 over coefficient A, change in concentration of A divided by change in time, that equal 1 over B. Note that there is no negative, so this is positive. 1 over B, change in concentration of B divided by change in time. Another example here, 2NO2 gives you O2 plus 2NO. So we can write the 2 is the coefficient here, and this is the reactant here. So negative 1 over 2 change in concentration of NO2 divided by delta T, that equal positive change in concentration of O2 divided by change in time, positive 1 over 2 because the coefficient is 2 here, change in concentration of NO divided by change in time. Another example, 4pH3 gives P4 plus 6H2. We can write rate equal negative, because this is the reactant, so negative 1 over 4 change in concentration of pH3 divided by change in time, that equal positive change in concentration of P4 because that's the product divided by change in time, that equal positive 1 over 6 change in concentration of H2 divided by change in time. Another example is 2NOCl gives 2NO plus Cl2. So here the coefficient is 2, so negative because that is a reactant. So negative 1 over 2 change in concentration of NOCl divided by change in time, that equal positive 1 over 2 change in concentration of NO divided by change in time, positive, that equal positive change in concentration of Cl2 divided by change in time. And now the reverse question. So that means write a balanced equation from the rate expression. So what we have to do is we have to look for the sign. So this is negative. So this is going to be our reactant. And there is a 2 here that is going to be our coefficient for the reactant. So 2N2O5 will give us, this is positive and this is positive. So I have two products here. So the coefficient is 4NO2, and here there is no number, so that means it's going to be 1O2. So the equation is going to be 2N2O5 gives 4NO2 plus O2. Another type of question here, dinitrogen monoxide. So dinitrogen monoxide decomposes into nitrogen and oxygen when heated. So nitrogen and oxygen. So I have to balance it. 2N2O gives 2N2 plus O2. And the initial rate of the reaction is 0.22. So first I have to write the rate expression for that. Rate equal negative 1 over 2 change in concentration of N2O divided by change in time, that equal 1 over 2 change in concentration of N2 divided by change in time, that equal change in concentration of O2 divided by change in time. So what I have to do, I have the rate there. We have to connect only N2O we have to consider because that's a question asking for. So rate equal, I will just take that one, 1 over 2 change in concentration of N2O divided by change in time. So rate is given, which is 0.022, that equal negative 1 over 2 change in concentration of N2O divided by change in time. They are asking only for change in concentration of N2O, so I have to isolate that one. On both sides we can multiply it by 2 and we will get 0.044, that equal, this one will cancel and we will have negative change in concentration N2O divided by change in time. So that negative can be this side, so answer is going to be negative 0.044 molar per second. Let's see another type of question. So Cl2 plus 3F2 gives 2ClF3. So the rate of disappearance of F2 is 1 molar per second. What is the rate of appearance of ClF3? So let's go ahead and see. We have to connect F2 and ClF3. So what I will do first, I will write the rate expression, that equal, so there are two reactants, so negative change in concentration of chlorine divided by change in time, that equal negative 1 over 3 change in concentration of F2 divided by change in time, that equal positive 1 over 2 change in concentration of ClF3 divided by change in time. So we have to connect only fluorine and ClF3. So I'm not going to talk about this one now. So that means what is the rate of appearance of? So they gave us for the disappearance of F2. So that means negative 1 over 3 and the disappearance of F2 is 1. That equal 1 over 2 we have to calculate for ClF3. Okay, so in that case what I will do is I just have to isolate that part here, right? So we can multiply on both sides by 2. So 2 and 2 will cancel. So 2 over 3 will equal 0.6666. So that means that is approximately, I can say 0.67 molar per second is the answer for change in concentration, that is the rate of appearance of ClF3. Change in concentration ClF3 divided by delta T equals 0.67 molar per second. So we can measure the reaction rate either as average rate or instantaneous rate. To find the instantaneous rate, we can use a graph. Say for example here, to find the instantaneous rate at this point, what we can do is we can draw a tangent, a line that passes through that point, and we can take the slope of that line. So that will give us the instantaneous rate. And to find the average rate, say for example, we have to find the average rate from 100 to, say for example, 250. Okay, so 250, we will find a point here. And for 100, we will find a point here. So what is the concentration here at 100? What's the concentration at 250? We will find the difference and the change in time, 250 minus 100. So that is how we will find the average.